So let's begin with linear differential equations. So recall that the linear differential equation looks like this. Let's see if the right hand side is indeed continuously differentiable. So let's compute df dt and df dy. So now, in order for these two functions to be continuous, we just need to make sure that p prime and q prime are continuous. So which means that p and q have to be continuously differentiable. Right. So from now on, let's assume that the coefficients of the linear equation are continuously differentiable functions of t. Right. Now let's think of the domain. In general, when you find the domain of any function, what you really need to think about is which points do not belong to the domain. So in other words, for which values of the independent variables your function is undefined, when you cannot compute the value. Right? So you should think of what if you try to compute the value, what can go wrong. And basically what prevents you from computing is presence of division, so then the denominator cannot be 0. Logarithms, so then the input of the logarithm should be positive. Inverse trigonometric functions, so like inverse cosine, the input should be between -1 and 1, and so on. But here, obviously, nothing can go wrong with y. So for any value of y, the right-hand side makes sense. There is no division by y or anything, because it's a linear equation. Right? So something might go wrong with t. Right? So in order for the right-hand side of the original ODE to be defined, both p of t and q of t must be defined. So in other words, it means that t must belong to both the domain of p and the domain of q. Hence we get this answer. Alright, a few examples. So here we have the square root of some expression. Right, so in order for it to make sense, t minus 1 times t plus 2 must be non-negative. So roughly speaking, if we try to plot, right, so 1 minus 2, t minus 1 times t plus 2, then it is positive here, negative here, positive here, so it looks like a parabola. Right, so which means that for t minus 1 times t plus 2 to be non-negative, either t must be bigger than 1 or t must be smaller than negative 2. But strictly speaking, the signs should not be sharp, so it should be like this. But recall that in the beginning I mentioned that domains must be open sets, so that's why I'm changing this non-open set to an open set. Right, so in other words, what you see here is that the domain is just completely separated. So we have one area in the domain is when t is bigger than negative. There is a typo error, of course. Should be either smaller than negative 2 or bigger than 1. In a way, you can treat this single differential equation as just two completely different problems. So in one case, t is less than negative 2, and in the other case, t is bigger than 1. So that's the reason you can do it is because it is a linear equation. So that's why the two parts of the domain are completely separated. So you cannot have a solution that begins when t is negative 2 and somehow enters the area when t is bigger than 1, is because it will have to cross this empty area where there is nothing. So that's why you don't even have to think about it. So you can just assume that these are two unrelated problems.